So the first one they ask us about is angle 3. Angle 3 compared to angle 2, those would be vertical angles. So that's 97. Angle 5. Now, angle 5 is over with the green line. And together, these two make up that semicircle. They make that straight line. So that's 180 degrees.
From 5 to 6 is 180 degrees?
Yes. So real quick, that would be 180 minus 88, which is 92. And that's just a quick little math that you should do to the side. You'll do that a lot through this unit. So 92 degrees. Number 10. So number 10 has nothing to do with over here. Number 10 is in the same position as number 2. So we call those corresponding angles. So that's also 97 degrees. And number 9 is supplementary with number 10. So 180 minus 97 is 83. Measure of angle 7 is vertical to angle 6, or you can say it's supplementary to angle 5. You can do that either way. So you can take that these two should add up to 180. Vertical is just easier to say that 7 is the same as 6. So 7 is going to be 88. And then for angle 16, there's several ways that you can go about finding 16. But the fastest way is to say that 16 is alternate exterior angles with angle 5. So they should be the same exact thing. So that's going to be 92.
Could you say 12 and 2 would be alternate exterior angles as well, or no?
Not 12 and 2, no. 12 and 1.
I'm sorry, 11 and 2.
Yes, 11 and 2, correct. Yep. Yeah, so these properties kind of, some of them prove each other. So some of them, there's shortcuts. Some of them, there's longer ways to do it. All right, number 10, we have the measure of angle 4, which is 77. And 8 is 4x plus 57. So if we're solving for x, we know we have to create an equation. So that equation is going to either be one of two things. They're either going to equal each other because the angles that they identified are congruent, or the angles are supplementary, meaning they should add up to 180. In this case, we know that 4 and 8 are corresponding angles, so they should equal each other. So 77 should equal 4x plus 57. So we're just going to solve that real quick. So x equals 5. The next one, we have the measure of angle 6, so 5x plus 13. And then measure of angle 5 is 53. Now those two angles are next to each other. Notice that arc that they create together. So that's 180 degrees. So these two are going to add up to equal 180 degrees. I'm going to subtract that 66. So 5x is going to equal 114. Divide both sides by 5. X equals 22.8.
So decimals are okay with angles?
Yeah, absolutely.
Okay.
All right, next one we have angle 1 and angle 7. So angle 1 is 6x minus 5. And angle 7 is 115. So those two angles are alternate exterior angles, which means they are congruent to each other. Usually they're going to be congruent. The only time that they will not equal each other is supplementary angles. All the other properties say that they are congruent. So we're going to add 5 to both sides. So 6x equals 120. Divide both sides by 6. X equals 20. Any questions on that front page? All right, then. So on this next page, I'm really not going to go over much of 13 through 16. It's really what we just did on the previous page. Just keep an eye out for, should they equal each other or should they add up to 180? Like I said, more times than not, they're going to equal each other. The only time that they will add up to 180 is if they're supplementary. So basically, you want to say, how do these two angles relate? Do they relate in a way that they should equal? Or should I add those two things up to equal 180? And I'll just set them up. I'm not going to go through and solve them all. So we'll just identify them and then we'll set up the equations. These two angles are alternate interior angles, so they should equal each other. These two angles are supplementary, so they should add up to equal 180.
I'm sorry, for number 13, did you say that it was alternate exterior or interior angles?
Alternate interior angles.
Thank you.
Yep.
Terms and divide it out at the end.
Say that 13. For 14?
Combine like terms there.
So for 13, you need to get the like terms on the same side first. So you need to bring the 3x over here and bring this 10 over here. So that would be 20 equals 2x. X equals 10. So there is two different methods. It's actually a good way to look at them right here. Whenever you set them equal to each other, RJ, you're going to have to get the like terms on the same side first. Whenever you're adding them up to equal to 180, usually the x's will already be on the same side to combine like terms. For 15, we have corresponding angles. So these are going to equal each other. So notice how the x's are on different sides. So we have to do the opposite. So we would want to subtract the 5x there to bring it over. Number 16, these are alternate exterior angles. So they should equal each other. Notice 3 out of 4 times here, they equaled each other. Again, we want to get the x's on the same side first, get the constant terms on the same side. So we can't just start combining like terms quite yet. Anyone need to see 13 through 16 solved out further?
I'm good.
Okay. All right, 17 through 20 here. If we're trying to find x, what we have to keep in mind that we're also given the idea that this larger exterior angle, I should say external angle here, is 90 degrees. And we can see that from this marking right here. So that means if this right here is 50 degrees, how much further do I have to go to make a full 90 degrees? So those are complementary angles, not supplementary angles. They're complementary angles, meaning x plus 55 should add up to 90. So x is 35 degrees. Same thing with 18. We have this idea that they are complementary. You don't have to set up the equation for that. If you just want to kind of do it more logically and say that, well, if the whole thing's 90 and I take away that 47, I'm left with 43 degrees. Sort of how we did with the 180 earlier. We didn't really set it up formally. This will give you a little bit more understanding. Once you get the hang of it and see what's going on, you might resort to just kind of that quick setup. Either way is fine. Same thing down here. Remember, these are kind of the angles we are dealing with earlier. So this would be like maybe the top part of parallel lines. Right? So they're supplementary. But they can just exist on their own, which I kind of mentioned earlier. So A plus 67 should equal 180. Kind of writing this out more formally. So that's 113 degrees. Or like what we were doing earlier, we were saying if that together makes a straight line or a semicircle, then we can just take that 180 and take away the 122. And we can say B is 58. Any questions on those four?
No, I'm good.
Okay. All right, this page is very redundant. The idea is, I'm actually just going to do one of these. If you have one angle, you can figure out all other, the 7 other ones. So 8 total angles, you only need 1 to get started. Many different approaches to this. My approach usually is I go after my vertical angle first. So this is 140. These are supplementary, so 180, take away that 140. So that's 40 degrees, which makes this 40 degrees. And then these 4 are the same as these 4 because of the idea of corresponding angles. So 140, 140, 40, and 40. And that's it. That's how they'll all be done. Really, 3 ideas were used there: vertical angles, supplementary angles, and then corresponding angles. We could have used alternate interior or alternate exterior, but we don't have to. I'm going to go to the next page if there's no questions on that. Really, I don't think the problems really get any more unique from here on. Same idea. We want to understand, should we set those equal to each other, or should we be adding those up to equal 180? Okay. All right. Paul, me and you did this one together yesterday. I'm going to go over it for everybody else. There's 3 things that we need to see here. One thing we need to see is we have a triangle overlapping with another triangle. So maybe you don't see the two triangles, but you definitely want to see that we have two triangles there. We know from the one formula that we have S equals 180 times n minus 2. So that's the sum of interior angles. We know that a triangle should add up to 180 degrees. And we also know a quadrilateral, or something with 4 sides, like right here, should add up to 360 degrees. So those are the two ideas that we're going to use. Now there's going to be some other things in there to help us out. But those are two ideas that are going to help us get through this problem. So looking at the red triangle, I have 2 of the 3 angles. So that means I can find out the third angle because all 3 of them should add up to 180. So 74 plus 55 plus Z should equal 180. That means that Z equals 180 minus 74 minus 55, 51 degrees. All right, so my next step, I'm going to immediately go to that blue triangle and see, can I do the same thing with that blue triangle? Well, for the blue triangle, I only have 1 of the 3 angles. So as soon as I find out angle W, I'll be able to find angle V. So I'll come back to those. I'm waiting to get W first. Now, in order to get W, since it's part of this 4-sided polygon, I know it adds up to 360. So I could figure out W as soon as I figure out both X and Y. Now, X is going to be a little bit easier for us to find because it is vertical to 115. So it is also 115. Also, Y is supplementary with 45. So Y plus 45 should equal 180. So that means Y equals 135. Now I can find W. So W plus 115 plus 51 plus 135 should equal 360. That means W equals, you don't have to set it up that formally. Really what I'm doing is 360 minus 135. I'm taking away the 51. I'm taking away the 115, and that equals 59.
Hey, Johnny.
Yes, Paul.
Yeah, 57.
It should be 57?
Yeah.
Is that what we got last time?
Yeah.
We were wrong last time. We subtracted wrong. Let me double check now. Yeah, it should be 59. And now we can find V. Because V plus 59 plus 72 should equal 180. $49. Here we go. Questions on that. There will be one, I call that like a puzzle style question on your assessment. Not saying it'll be as hard as that one, but just something to kind of get you guys using the properties to kind of work your way through it to find a missing angle. You saw 4 of those on the homework. Right down here. Does anyone think they got these 4?
I did.
Paul? Good. Paul, I know we did what, 13 and 14 together.
Yes.
All right, we're going to skip ahead to the review now. We're just going to bounce around through these problems. I'm going to do number 1 and number 3. Actually, no, I'll do 1 and 2. So the one thing you have to pay attention to when we use this formula, did I give you something to plug in for N, or did I give you something to plug in for S?
Plug in N.
Right, so here, 15-sided polygon. So N.
S, right?
N equals 15 right here. So the number of sides is N. S is the sum. So this is going to be S equals 180 times 15 minus 2. So that's 180 times 13. Which is 2340. Number 2 is the other way. Number 2, we're saying that S equals 3060. So this is going to be 3060 equals 180 times N minus 2. Now, I know a lot of you are going to distribute that 180, and that's perfectly fine. It's just one extra step if you do it that way. If we divide by 180 from the beginning, because we'd have to divide by 180 at the very end anyways. Oh, that's 17. And now we can just add 2 to both sides. Okay. 3 and 4 are similar. 3, I don't tell you how many sides, like in number 1, but I do say it's an octagon. So you will want to know how many sides there are if I give you the formal name of the polygon. All right, for the next 2 problems, for solving for x, we need to create an equation. We need to decide, should I be adding these 2 up to equal something, or should I be setting them equal to each other? Sort of the game.
For 2.
Say that again, Paul.
Set up to.
Set them to equal to each other, you said?
Yeah.
Not in this case, because now they tell us that DEF equals 83. And if I highlight DEF, I can see that that's the entire angle made up by those two inside angles. So DEH is right here. HEF is right here. So the blue and green together make the red. So I'm going to add those up. So DEH, which is 6x plus 6, plus that green angle, which is 9x plus 2, equals 83. Combine like terms, we have 15x plus 8 equals 83. Subtract 8 from both sides. That's 15x equals 75. X equals 5. So make sure we answer the question. Yes, we did find X, but now let's take it and plug it back in. That means 6 times 5, which is 30, plus 6 equals 36 degrees. 9 times 5, which is 45, plus 2, which is 47 degrees. So there's one answer, and there's our other answer. Notice if we try to do that same strategy in the next problem, we would realize that we do not know what ACB is. So we cannot add up these two angles to equal anything. Instead, the idea that we have is that CL is an angle bisector, which means it splits these angles in half, meaning these two angles are congruent. 5x plus 27 equals 8x. So I'm going to subtract 5x from both sides. So I'll get 27 equals 3x divided by 3. X equals 9. Again, it's asking me to find ACL and BCL, so let's take this back. If it said just find X, we would be done. So that's 45 plus 27, which is 72 degrees. Here we have 8 times 5, which is 40 degrees. Oops, not 5. 9. 72 degrees. So I caught myself because I knew they were both supposed to be the same thing. So when I plugged in that 5 and got 40, I knew it was supposed to be 72. All right, any questions on those two problems?
I'm good.
All right. All right, so we kind of had one like this, but I'll go through one like this again. It looks more intimidating than it really is. Just try and focus on a couple things here. Well, actually, try and focus on one thing at a time. Here's the two parallel lines. And here's one of the transversals, or one of the bridges. So just focus on that right now. Focus on these 4 angles. Follow the red bridge down to the other blue line, and make sure you understand that those 4 are going to be the same thing. So I'm going to take care of that first. That means that this is also 31 degrees, because they're vertical angles. These should add up to 180. So 180 minus 31 is 149. That means this is also 149. So those 4 angles, I'm going to follow down and replace it down here. So 31 degrees, 149 degrees, 31 degrees, and 149 degrees. All right, so there's 8 angles right there. Now our intuition is going to say, well, let's go do the same thing with these 8 angles. But we don't have a starter angle. We don't have one of them that's basically going to unlock the other 7. So we need to find another way to get at least one of those opened up. And that's where this triangle is going to come into play.
Mr. G.
Yes. Go ahead.
Mr. G, wouldn't the other 8 angles, like the one directly across from the ones we just solved on the top and the bottom, wouldn't they be the same angles, just flipped?
No. No, not necessarily.
Oh, okay.
Yeah, that would.
They look the same, so I was.
They do, but we can't go off of our eye. There would have to be something. If we knew what the slopes of the red and the green line were, then maybe we could do that.
Okay.
But we don't. So we're going to be able to find this angle, which will unlock these angles. So this triangle, we know, should add up to 180 degrees. So 180 minus 31 minus 74 is 72 degrees. Let me just double check that. Nope, 75. So if that's 75, that means that this is also 75.
You're doing it. I was right. It's 75.
That's
right.
It is 75?
Yeah.
Thanks, Paul. If that's 75, that means that these have to add up to 180. So 180 minus 75 is going to give us 105, which means this is 105. And now I could take those 4 angles and bring them down here. 75, 105, 105, and 75. So we have everything except these four in the middle. Now these four in the middle have nothing to do with any of these intersections because they have nothing to do with the blue parallel lines. It's just the intersection of two lines. But that doesn't mean that we don't have vertical angles and supplementary angles. And we're done. So no matter how complex it looks, try and pinpoint your focus on small regions and see if we can use the same ideas over and over again. I like to look for vertical angles first and then supplementary angles and see how far that can get me. All right, next one. Again, I'm gonna look for vertical and supplementary. So vertical jumps out at me right here. And then supplementary. So there's those four. I can follow the transversal up and we hit another parallel line. And I know they're parallel because of these markings here. So since they are parallel, it allows me to basically copy and paste those four angles. All right, I'm going to bounce up here to this 123 because these together are supplementary. So 180 minus 123. That's 57. And then I have one more missing angle, which is the third angle of this triangle. So that means if I do the 180 that they should all add up to, take away the 107, take away the 57, we get 16 degrees. Any questions on that one?
I'm good.
Okay. All right. There we go. All right, this last one's a little bit more complex, but there are some things that we could write down here and some things that we need to notice. One, we have X's and we have Y values. So we have two variables that are unknown, so we need to be careful when we set up our equations. We would like to set up equations that only involve one type of variable. I'm going to fill in 2x plus 4 real quick here, just because I rather have an algebraic expression there than a question mark, because these are vertical. And now let's try and make equations that only involve x's or only involve y's. So the first one that I see is that these two angles only involve x's, and together they should add up to 180. So that's 13x minus 2 equals 180. $13x equals 182. X equals 14. So if I plug that back in, that's 28 plus 4, which is 32 degrees, which means this is also 32 degrees. This is 11 times 14 minus 6, which is 148. And now we can focus on the y variables. Now there's two ways we can think of this. There's actually more than two ways. One, we can say that all three of these angles should add up to 180. We don't know what these two by themselves should add up. Actually, we do. These two angles should add up to 148 because these are vertical. So there's another way. I didn't even see that one at first. So we can add up these two to equal 148. We can add up these three to equal 180. We can add up these three to equal 180. Or we can add up all 5 to equal 360. So that is up to you. I'm going to go with 8y plus 6y to equal 148 because that involves less things for me to write down. So that's 14y equals 140. I just combined my 8 and my 6y, subtracted my 8 to the other side. So that gives me y equals 10. So that's 60 degrees. And that's 88 degrees. All right, that's the last one. This last page, you guys can forget about it because we don't have the things we need to measure those. We kind of skipped over that idea. Any questions on any of the review problems, anything we missed?